All right, so then today we'll just cover 5.7 real quick. It's called the Binomial Theorem. And your learning target to go with this one is that you can use the Binomial Theorem, which we'll learn about here in a second, to expand binomials. Okay, so we'll basically we're going to learn a shortcut to do something like you know, what we see on our screen right here, a plus b cubed, right? So if I told you to simplify that right now, you would have to you know, there is no shortcut, so you would just have to take a plus b times a plus b, and whatever that is times another a plus b, right? So that can get really repetitive, and you know, if we look at some of our later examples, well, this one right here, a plus b to the sixth, right? So that would just take forever, okay? And so we're going to learn a shortcut, basically, to how to expand that out, all right? So one part of the shortcut has to do with this thing called Pascal's triangle. You may have heard of that before. You may not have. It's no big deal, really. But it is just, Pascal's triangle is just a... it's just a pattern, okay? That's all it is, right? So if I did ask you to do this problem or one of these problems on a test, you would not really need to have Pascal's triangle right in front of you because this is easy to reproduce, right? So the top row starts with 1, row 2 is just 1 and 1, and then row 3 is 1, 2, 1. Where am I getting the 2 in the middle? So does anybody see the pattern yet? Like, how am I getting that 2 right there? Yes, Ryan? Right. You're the 1 plus the 1 above it gives you the 2, right? And then if you look at the next row, 1 plus 2 is 3, right? So it's easy to reproduce Pascal's triangle. So one last thing on this, and then we'll get into the why. Let's write out which row each one is, right? So we would call the top row not row 1. This would be row 0. And then row 1 would be that one, row 2, 3, and so on. Whoops, row 6. All right, and then if you needed to write out row 9, then you know you could you know, it would start with a 1, and then 1 plus 8 is 9, and then you'd be off and running. But we're not going to do that. Okay. All right. So we'll come back to that later. Okay. So let's get into kind of how it works when you're using the binomial theorem. So this is at the bottom of page 1. It says when expanding a plus b to the nth. All right. So powers of a, which is your kind of your lead term of your binomial, they are going to ascend. So meaning get bigger. Ascend from. Sorry, I did that wrong. They're going to descend. The next one ascends. Sorry about that. Powers of a are going to descend from whatever your exponent is, so in this case, n, to 0. Powers of b, which is your second term of your binomial, they're going to ascend from 0 to n. All right, the sum of the exponents. So there's an exponent on the a term, there's an exponent of the b term, or on the b term. The sum of those exponents is always whatever n is, okay? So we can just say equals n. And then the coefficients come from, here's where we use Pascal's triangle, okay? So coefficients from Pascal's triangle. So you'll just use your notes for that part because it's already pretty much written out. And I don't think you'll be asked to expand anything over, something to the 8th power. Okay, so you have all the rows you need. All right, so let's go ahead and do an example of this together. We'll go ahead and expand a plus b to the 6th. And remember, why we're doing this, why we would want to know this shortcut is because if we didn't have the shortcut, that would mean, don't write this out, but we'd take a plus b times a plus b times a plus b, right? And you just have to keep going, and it would just take forever. You can imagine how time-consuming that would be, right? So this is a shortcut in order to alleviate some of that time. All right, so looking at the exponent to the 6th power. So that tells you that you want to know what's row 6 of Pascal's triangle. All right, so row 6. So we could just look up at our already written out Pascal's triangle, and we're looking at this row right here. So I'm just going to copy that 1, 6, 15, da 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 da. And you can, I know it's tough to flip back and forth, so you could just take my word that it's 1, 6, 15, 20, 15, 6, 1. So it's, it's hard just to pull out a random row, right? You can build a row from the previous row, but without row 5, row 6 is tough. So you just look back, at the already written out thing. Okay. So those are going to be our coefficients, and then we'll just remember powers of A are going to start with 6 and descend down to 0. Powers of B are going to start at 0 and ascend up to 6. All right, so here's how it works all together. Okay. All right, so we have our coefficient of the first term is going to be 1. And then we have A raised to the 6th power, and then B raised to the 0 power. So whatever that is, and we'll simplify it here in just a second. Okay, the coefficient of my next term is 6. And then remember, my powers of A are descending, right? So it was a to the 6th before this, so it's a to the 5th on this term. And my powers of B are ascending, so I'm going from 0 to this is B to the 1st. All right, now my next coefficient is going to be 15. Anybody know what my exponent for A is? 4, right? And what would my exponent for B be? 2, very good. 4 plus 2 is 6, right? They always add up to 6. So you'll start to see the pattern as we go. My next coefficient is, anybody know it? Not 3, 20. 20, that's right. And then, yeah, it's A to the 3 and B to the 3. You got it. All right, so you have 3 more terms to go. I'm going to write them up kind of quietly, and so you can try to do it on your own, okay? Or you can just copy if you don't get where I'm getting these numbers yet. All right, so sorry, got a little sloppy there at the end, kind of ran out of room, but so eventually you shouldn't necessarily need to show all this work, but we're kind of introducing this idea. I think showing the work explicitly this way kind of shows you where everything comes from. Eventually, if you get decent at this, really you should only have to write out maybe the row of Pascal's triangle you're using, and then be able to use your calculator from there to simplify term by term. Okay, so that's our last step, is just to simplify each term, make it look pretty, and this would be our final answer, right? So looking at the first term here, 1 times a to the 6 times b to the 0. Does anybody remember what anything to the power of 0 is? 1. That's right. That's just one of those things that doesn't necessarily, it's not necessarily intuitive, but you know, it's just one of those things we remember. So really our first term is just 1 times a to the 6 times 1, right? So just a to the 6 all together. Our next term is 6 a to the 5th times b to the 1st. So we would just write that as 6 a to the 5th times b. Our next term, 15 a to the 4, b to the 2. Then we have 20 a cubed, b cubed, and so on and so forth. So I'll read that out one last time. Our final answer, when it's simplified, says a to the 6th plus 6a to the 5th b plus 15a to the 4th b squared plus 20a cubed b cubed plus 15a squared b to the 4th plus 6ab to the 5th plus b to the 6th. Okay, so you can see these do get a little time consuming, but we'll show a little bit less work maybe on the next one. Okay. All right, so let's just jump right into the next example. I won't take questions yet. It's to expand x minus 5 raised to the 4th. Okay, so one thing we're gonna want to take note of here is we want row 4, which you can just, if you want to turn your page around, you can, but it's 1 4 6 4 1. 1 4 6 4 1. So those will be my coefficients. And then another challenge here compared to the last one is you have like b is -5. So we'll see a pattern with the signs here too. All right. But for now, we'll just we'll continue to write out each term. So we'll have, you know, altogether 1, 2, 3, 4, 5 terms, right? So my first term is going to be coefficient 1. And then we have x to the, anybody know where we start with our exponent for x? 4, right? What would my exponent for -5 be? Anybody know? 0. Very good. Okay. Next one would be 4 x cubed times -5 to the 1. And then we're kind of off and running. Next term would be 6, then x cubed, and -5. Sorry, should have been x squared, and -5 squared. Then we have 4 times x to the 1 times -5 to the 3. And then our last term would be 1 times x to the 0. Really, you could just leave that off if you wanted, times -5 to the 4. All right, so when we simplify each term, okay, so my coefficient of the first term is just going to be 1 times -5 to the 0, really, so that's just 1 times 1, okay? So my first term is just simply x to the 4th. Now my next term, my coefficient is, I'm going to use my calculator here just to be safe, it's going to be 4 times, when you do -5, you want to put it in parentheses. So -5 to the 1st, you could just type that as -5, but that's going to be -20. So my coefficient is -20. So my next term is -20 x to the 3rd. Okay, now my coefficient of the next one is going to be the product of 6 times -5 squared. So that's 150, right? So that's plus 150x squared. Okay, now my coefficient of the next term is going to be 4 times negative 5 cubed. Whoops, typed it in wrong. Try that again. So that'd be minus 500. And that's x to the 1. And then my last coefficient is just going to be 1 times 1. So it's just going to be my constant. So it's going to be whatever negative 5 to the 4th is. So that'd be 625. So what pattern, as far as the signs go, what's the pattern? Just looking at the signs. Anybody see a pattern with the signs of each term? So first term's positive, then negative, positive, negative, positive, right? So it just alternates. And that's the way it'll go if you have a negative, okay? They alternate because when you take a negative base to an even power, it's positive, all right? All right, so let's just do one of the next two together, and then I will leave the rest for you to do some. You can have some work time. All right, I'll leave B just for if you want to look it up on the filled out notes. That's fine, and we'll finish with C together. All right. So go ahead and we'll start with row 5 from the triangle. That's 1, 5, 10, 10, 5, 1. Okay, so I'm gonna talk a little bit less during this one. So if you feel like you get it, you could try it and check as you go or as you finish, or you can just stay right with me. So I'm gonna talk a little bit less, but if you have any questions, you just let me know. All right, so all the work and answer is up there. So take your time to kind of try to get finished with it and then check it if that's what you're doing. or finish copying it down if you weren't quite there yet. So I would just say that it's a little bit tougher on this one to get from what I have written in black, which is just kind of plugging in, plugging in your terms into the pattern, to what I have written in green, which is where we simplify. So if anybody wants to see a couple of those, how I would type them in to get my coefficients like 32 or negative 240, like that's what you're using your calculator for. If anybody needs help seeing any of that, just let me know, okay? While you're doing that, I'm going to go ahead and post the Math Excel for those of you who get it, and then you can go ahead and get started, and then we'll have a little friendly competition on our way out the door today.